Okay, you're recording in progress. So here's the screen. Okay, so we're over here, continuing on trig. I'm already in the 4.4, and I may be able to finish much of 4.4 by today. So hopefully that's what we're aiming for. Okay, so I'm a day ahead, but I messed up the schedule, and we still have to do 4.9, of course, as we see here. Okay, so we're right over here, 4.4, 1 to 55 odd. So let me just continue on with where we were last time. Okay, so we did reference angles, and now find sine and cosine for the given values of t. So let me show you the strategy behind some of those problems. Okay, number 7, t is pi over 6, 30 degrees. Okay, so as I mentioned the other day, one thing you want to keep in mind for reference angles of 30 and 60, either x or y is going to be a half, plus or minus, and 1/2 is always paired with radical 3 over 2. Okay, so one thing I always like to do is if I have pi over 6, I know that's 30 degrees, draw myself a 30-degree angle in standard position, and then I ask myself, does it look like x or y is halfway across the circle? Right, this is the x, that looks like more than half. That looks like the y, that seems closer to half. Your circle doesn't even have to be that exact. Okay, your angle doesn't have to be that exact. It should be pretty obvious. One of them is definitely more like a half than the other. So that tells me the y coordinate is a half, x coordinate is automatically radical 3 over 2. All right, so cosine means x coordinate, sine means y coordinate. It's alphabetical order. So cosine pi over 6, radical 3 over 2, sine of pi over 6, 1/2. Okay, that's the way it works. Yeah, how about 15? Negative pi over 3. That is negative 60 degrees. Okay. It is good if you can start memorizing the key angles, but if not, you can always do the conversion factor, right? Multiply by 180 over pi or pi over 180, as the case may be. Okay, so like for this one, yeah, why don't I go ahead and write it in? Let's see, you would want to cancel the pi, so 180 degrees over pi radians, pi's cancel out, so negative 60 degrees. So I drew myself an angle of negative 60 degrees. Okay, there's x, there's y. Y looks like more than halfway across. X looks like it's halfway across. So 1/2 comma radical 3 over 2, but I'm in quadrant 4. Quadrant 4, y is negative, x is positive. And there we go. Cosine x coordinate. Cosine negative pi over 3, 1/2. Sine of negative pi over 3, negative radical 3 over 2. Okay. That's how you want to analyze stuff like that. We'll do more, many more. Okay, negative 5 pi over 4. Well, I think of positive 5 pi over 4 is in the third quadrant, it swings all the way to here. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So positive 5 pi over 4 is like that. It's a little bit more than halfway. So I have to think of going backwards the same amount, negative 5 pi over 4. It's up here. And then I say, oh, that is a reference angle of 45 degrees. So if I have a reference angle of 45 degrees, automatically both x and y are radical 2 over 2 plus or minus. So I immediately just put radical 2 over 2 for both of them. And then I think second quadrant x is negative, y is positive. So cosine negative 5 pi over 4, x coordinate, negative radical 2 over 2. Sine of negative 5 pi over 4, positive radical 2 over 2. So that's the game that we're playing. And so once again, you want to keep this picture in mind. On a unit circle, given a theta, x comma y is the same thing as cosine theta, sine theta. So on a unit circle, here's the angle. The x coordinate is cosine theta. Y coordinate is sine theta. Okay. 23, negative 7 pi. Okay, this looks almost dizzying, but negative 7 pi, I go backwards. Once is negative 2 pi. Twice is negative 4 pi. 3 times is negative 6 pi. And then another negative pi. So it lands me here. So it's 3.5 revolutions in a negative sense. And so back 1, that's what these swirls are. Negative 1, negative twice, negative thrice, and then up to here. So what is the ordered pair? Here, negative 1, 0. All right, so that tells me cosine of negative 7 pi is negative 1, sine of negative 7 pi is 0. Okay. So that's the basic idea behind almost all of these. Okay, draw the angle, figure out the reference angle. For angles that have a reference angle of either 30 or 60 degrees, there's going to be a plus or minus half there. Figure out which one is halfway. The other is automatically plus or minus radical 3 over 2. If the reference angle is 45 degrees, automatically they're both radical 2 over 2. Just plunk it down and then determine the SIGN after that. All right, 25, 45 degrees. Well, that's about as standard as you can get. Radical 2 over 2, both of them. So cosine 45 degrees, radical 2 over 2, which is about 0.7. Sine of 45 degrees, also radical 2 over 2. It's also about 0.7. I think it's like 0.7071, as I recall. Square root of 2 divided by 2. 0.7071, blah, 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 blah. Okay. All right, 27, 150 degrees. Okay. Well, I know this is 180. Here's 150, 30 degrees back of 180. Okay, so I'm right here. Does it look like X or Y is halfway across the circle? If you look at X, that's way more than half. Y looks like it's a half. So I put the Y coordinate as a half, which automatically means the other number is radical 3 over 2. And then the correct sign, SIGN, second quadrant, negative. So there I go. Cosine of 150 degrees, X coordinate, negative radical 3 over 2. Sine, SINE of 150 degrees, Y coordinate, 1/2. Okay, so I think all the angles that have a reference angle of either 30 or 60, just look and see which seems like it's going to be plus or minus a half. The other coordinate is automatically plus or minus radical 3 over 2. Okay, 29, 240 degrees. Well, let's see, 90, 180. This is 270, right? So I back up 30 degrees to 240. So I'm over here. It's 60 degrees more than 180. Now look at the X, look at the Y. Looks like X is halfway across, right? The X coordinate is halfway across. Y looks like way more than half. Your circle doesn't even have to be that accurate. You should generally be able to tell which is more likely to be halfway across. So for the X coordinate, I'm putting a half. Half is automatically paired with radical 3 over 2. And then correct signs, SIGN, I'm in quadrant 3. Quadrant 3, both X and Y are negative. And there we go. Cosine, 240 degrees, X coordinate, negative half. Sine 240 degrees, Y coordinate, negative radical 3 over 2. Okay. 31. (330°). No, this is 360. So I back up 30 degrees. It's 30 degrees off, I'm over here. There's the X, way more than half. There's the Y. The Y looks like it's halfway down. So Y, I'm going to put a half. The other coordinate's automatically radical 3/2. Check the quadrant. Quadrant 4. Quadrant 4. X is positive, Y is negative. So cosine 330°, X coordinate. Sine of 330°, Y coordinate. Okay. All right, so that's what's happening. 33 -60°. Well, I know a positive 60 is like that. So negative 60, I come down. And it looks like X is halfway. So I'm going to put X is a half. Y is automatically radical 3/2. I'm in quadrant 4. X is positive, Y is negative. Cosine of -60°, X coordinate, 1/2. Sine of -60°, Y coordinate, negative radical 3/2. Okay, then 37. 540°. Well, where are we? Go all the way around once is 360. 540 is another 180, so it lands me at the same spot as 180°. So I'm over here. It's 1.5 revolutions, right? 540, 360 plus 180, 540. The ordered pair is -1, 0. Cosine of 540°, -1. Sine of 540°, Y coordinate, 0. All right. So that's the basic idea behind those problems. Okay, now some problems a little bit harder at the end, 39 until the end. 39 to 46. Find all values of t in the interval from 0 to 2 pi that satisfy the given equation. Okay, so how do you do that? Cosine of t is radical 2/2. X coordinate is radical 2/2. And well, I know that radical 2/2 is going to give me something about 45°. So there's one there. Where else is the cosine positive? Quadrant 4. So my angles are pi/4 and 7pi/4. Pi/4, 2pi/4, 3pi/4, 4pi/4, 5, 6, 7pi/4. And even by the time you get back to 2 pi, that's 8pi/4. Okay. So my angles are pi/4, 7pi/4. Maybe I should have written it. T equals pi/4, 7pi/4. Check something here. All right, 41. Sine of t. So I think to myself, y coordinate, -1/2. So I draw a unit circle, come down half a unit, got an angle there, an angle there. That looks like 30°, 30°. Okay, so in radians, it's pi plus pi/6. That's 7pi/6. And what about this angle? If I go all the way around, it's 2 pi. I back up pi/6 and I subtract. 2 pi is the same as 12 pi/6. So 12 pi/6 minus pi/6, 11 pi/6. So these are my two angles. 45 is a little bit tricky because they have half an angle. Cosine of t over 2 equals 1/2. So here's the way I'm going to do it, and I want you to do likewise. I'm going to make a substitution. I'm first going to solve it with a letter that I like theta, and then I'll switch back to t. Now, in the direction it says t is between 0 and 2 pi. Let theta be t over 2. Okay, I'm just going to call that theta. I like just a single letter like theta. So theta is t over 2, which means t is 2 theta. If you multiply both sides by 2, I have this. And I work out this nice problem. However, let me see, if t is between 0 and 2 pi, what does it mean about the limitations on theta? So t is between 0 and 2 pi. If I divide all of these by 2, and I'll show you why in a moment, I have 0 less than equal to t over 2 less than equal to pi. The reason why I want to write that is I want to find out what the limits of theta are. Since theta is t over 2, I want an expression that has t over 2. So here it is. 0 is less than or equal to theta. Here's theta. Less than or equal to pi. So theta has to be between 0 and pi as I work the problem out. All right. So theta between 0 and pi, between 0 and 180 degrees, I want the x coordinate to be a half. How do I know it's x coordinate? Because it says cosine theta. Okay, so I go halfway across, go straight up, I figure out that angle. And yes, there's another angle here, but that would not be between 0 and pi. And that to me looks like it's 60 degrees, which in radians is pi over 3. So theta is pi over 3. However, the original problem was t, which is 2 theta. So 2 times theta, 2 times pi over 3. Final answer, 2 pi over 3. Okay. And then we had something about even and odd function. Let's see. 47. Determine whether the function is even, odd, or neither. F of x equals cosine x squared. It's more commonly written as cosine squared of x. So remember, for even and odd function, I replace x with negative x. F of negative x is cosine of negative x squared. But since negative x, cosine of negative x is the same as a cosine of x, I can write it as cosine of x, since cosine is an even function. And then I square it, and I get back cosine squared x. So f of negative x is the same as f of x. So I do have an even function. So 47 is even. '51 is a little bit different. I'll give you the gist of it. They give you sine of t is blah, 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 cosine of t is this. Find the sine and cosine of a given value. Okay, y coordinate, x coordinate. Y coordinate, x coordinate. Given. Sine is negative, blah, blah, blah. Cosine is positive 1/3. So here's the ordered pair. 1/3, negative 2 radical 2 over 3. Based on that, figure out the rest. So for instance, if it says t plus pi, well, you go 180 degrees off, that lands me here. A second quadrant. So I just reverse these signs. Okay, so I don't have space to write it. But for part A, put negative 1/3, positive 2 radical 2 over 3. It's reversed in sign. B, negative pi. Negative t. Well, that lands me here. Just make them both positive. So 1/3 comma 2 radical 2 over 3. Okay, then just a hint for some of these other ones. T plus pi over 2, you add 90 degrees. Right, so how do I add 90 degrees? I just come over here, and you can tell by symmetry, they're both going to be negative. I'm in quadrant 3. And this x coordinate becomes this y coordinate except negative. So negative 2 radical 2 over 3, negative 1/3 is the ordered pair. Okay, I'll let you take it from there. So that's a setup for 51. Okay, then the last one I was going to show you, then I'm done with the section, is 23. Find all t in the interval 0 to 2 pi, satisfying 2 sine squared of t plus sine t minus 1 equals 0. Write it like this. Okay, this is factorable. 2 sine t, 1 and 1, minus and a plus. Fold it back out, 2 sine squared t plus 2 sine t minus 1 sine t, that's plus sine t, then minus 1 equals 0. Okay. So by the zero factor property, either this one is 0 or this one is 0. 2 sine t minus 1 equals 0, or sine t plus 1 equals 0. A little bit of algebra. Add 1, divide 2, sine of t is a half. And here sine of t is negative 1. I.e., between 0 and 2 pi, the y coordinate is a half, or the y coordinate is negative 1. The y coordinate is negative 1, that's down here, south pole. Y coordinate is a half. So I go halfway up with this one over here and one over here. So where's here? That looks like 30 degrees, which in radians is pi over 6. This looks like it's 150 minus 180 minus 30, which is 150 degrees, 5 pi over 6. And this one I know to be 3 pi over 2. So here's my solution set for 53. T is pi over 6, 5 pi over 6, and 3 pi over 2. All right, and I am now done with the section 4.4. I can knock that off. I'm going to introduce some of 4.5, where we're going to be graphing sine and cosine functions. So introduce that in the meantime. What time is it? 9:35 or so. Okay. Graphs of the sine and cosine function. Page 220. They made up a table here. So do I have to copy that down? It's up to you. You don't really need it if you play the game that I did. Just draw your circle and say, does this look halfway? Does this look halfway? And so on. So here are different angles. Sine of the angle, i.e. y coordinate. If you were to plot all of these points, it ends up looking something like this. So here's the sine function. One period of the sine function from 0 to 2 pi, just right here. After that, it's just copy and paste, 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 and so on. So there's the sine function. You can do the same thing with the cosine function. So they made a table from 0 to 2 pi. As I go around a unit circle, x coordinate. So you can plot all these points. They've already done it for us. This is what it looks like. So here's one period of the cosine function. In case you're wondering, it does have the exact same shape as this. It may not look like it, but remember, this is infinitely long. So if you take this thing from here to here, right? Copy, paste, 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 paste. Do the same thing here. Copy this, paste, paste. You would notice that this graph looks identical to this graph. Just shift it over. So here's the cosine. Notice cosine of 0 is 1. And this is just to emphasize going more than one period. So from 0 to 2 pi, here is 0 to 2 pi. But being a periodic function, it keeps going, right? This keeps going like that. This keeps going like that, and on and on and on. And over here, same thing, up and down, and so forth. Something that might be useful if you want to put this on your cheat sheet you made. Sine function is odd. Therefore, it has origin symmetry. Symmetry with respect to the origin, they don't show you enough of it, but cross like so. Cosine is an even function. Therefore, it has y-axis symmetry. Cosine function. Put a mirror right here. Okay. This thing just reflects like so. Then we take our sine function or cosine function and move it. We've played this game before. Translate left, right, up, down. Okay. We'll play the game of stretch or shrink, both vertically and horizontally. Here's a regular sine function, y equals sine x, y equals 3 sine x. So like right here, the y coordinate should be 1. All of a sudden it jumps up to 3. Here the y coordinate is -1, it jumps down to -3. But notice all the zeros match, 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 match. And that's because 3 times 0 is still 0. Okay. Page 225. Well, I don't really like the way the book presents it. I'm going to do it my own way. So I think you should not even look at this. This is okay. Amplitude, how high and how low does it go? Absolute value of A. Period is 2 pi over B. Strictly speaking, it should also be absolute value, but most of the time they don't give you a negative value for B. So you can just say period is 2 pi over B. This stuff, even though it's correct, I don't really want you to use it. I'll approach it from the standpoint of factoring out the B. Besides, that makes it more consistent with what you learned before about horizontal and vertical shifts. Okay, and I'll show you what I mean when we get to that. Amplitude, absolute value of A, period is 2 pi divided by B.
Okay. Really quick, I recall my trig professor being like, negative periods are the same as positive periods. Like if it was -1, the period is still 1, or like, well, 1 being like.
Yeah, period is always a positive quantity, so we don't want period to be negative.
Okay, so if a period is negative, we just look at it as if it's positive.
Correct. It should be a positive number.
Okay.
And I'm getting the message your meeting will end in 10 minutes, so looks like we're still having that issue, but be that as it may. Okay. All right, and let's see. Let me show you the homework before we time out. And I'm a little bit ahead, I think. I wasn't supposed to start 4.5 until Thursday. Okay, I haven't really started it. Just giving an introduction. Okay, so let me show the homework for those of you who don't have the book and aren't getting it. See, 1 to 25 and 35, so 35 is the last one. It's on page 229. Whoops. And that. And that. Okay. Then page 230. Try to aim the book so that you can see both of them, left and right side. Actually, maybe you didn't have to do too many of these anyway. Okay, and see, was that it? I think that's it. We have to go up to 35. Yeah, so you don't really need any of these. Okay. We're done with that. All right, and let me just give you my own little spiel on what's happening, and we'll start graphing next time. So graphs of sine and cosine functions. Here are the quadrantal angles. Quadrantals are multiples of 90 degrees, pi over 2, pi, 3 pi over 2, 2 pi. So cosine of theta, x coordinate. So at 0, I have 1. Pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. 2 pi, 1. Sine of theta, I want the y coordinate. So 0, 0. Pi over 2, 1. Pi, 0. 3 pi over 2, negative 1. 2 pi, 0. Okay, now I could plot other points, and you've seen that before, but just a quickie graph. Okay, for the sine function. Okay. So 0, 0. Pi over 2, jump up to 1. Pi, you're back down to 0. 3 pi over 2, you're down at negative 1. 2 pi, 0. Okay, so the sine graph looks like this. And by the way, even though I have these points, don't draw it just in a straight line. Like don't go straight there, straight there, straight there. You see, how do you know it doesn't do that? Well, again, if you were to plot other angles, like pi over 6 and pi over 4 and pi over 3 and so on, you would see it curve more like so. The period of the sine function is 2 pi. I get a complete repeating unit right there. After that, it just becomes copy and paste. Copy, paste, paste, and on the left side also paste, paste, and so forth. The domain of the sine function is all real numbers. You can take the sine of any real number. The range, however, stuck between negative 1 and 1 inclusive. So bracket negative 1, 1. And here's the pattern for one period of the sine function. Starts up at 0. Then it goes to the maximum, 0, minimum, 0. This is 1/4 of the way, halfway, 3/4 of the way, full way. So that's one period of the cosine function. 0. Later on, we'll learn that it's not necessarily 0. It's what's going to be called the midline or the adjusted 0. Okay, but anyway, 0, maximum, 0, minimum, 0. Do the same thing for the cosine function, and I see I have 5 minutes left before I get bumped out. So for cosine, I have 0, 1, pi over 2, 0, pi, negative 1, that's down here, 3 pi over 2, 0, and 2 pi back to 1. So here's one period of the cosine function. So again, period is 2 pi. And again, the rest of the graph is copy and paste. Copy, paste, paste, and paste this way and paste that way, and so on. Once again, the domain is all real numbers. And the range is bracket negative 1, 1, just like the sine function. And here goes one period of the cosine function, starts at the maximum value. So it goes maximum, 0, minimum, 0, maximum. Okay, this is start, 1/4 of the way, halfway, 3/4 of the way, full way. Cosine goes maximum, 0, minimum, 0, maximum. One period of the cosine function. Now, here's the way I want you to do the problems for me in the text. So I do not want you to use the technique that the text has, even though it's correct. In other words, I don't want you to do 225. Okay. The way I'm showing you, of course, I'm biased. Everybody wants to do things their own way, but it's more consistent with what you learned before about translation, about vertical and horizontal shifts. That's my reason why. Okay, so to handle sine or cosine, there's going to be 1, 2, 3, 4 things that can change, 4 constants. Y equals, the most general is A, either sine or cosine. B, parentheses x minus c. So the way the book has it is there's a number in here. I'm going to factor that out. B parentheses x minus c plus d. Here's an example. Y equals 3, that's A. Sine of 2, that's B. Parentheses x minus pi over 4, that's C, plus D. So you already know from your previous work, this means pi over 4 to the right and 1 up. And that's consistent with what you had before. If you left a 2 inside, then you have to do some funny calculations, right? But this is very consistent with what we learned earlier in the course, right? Just look at this and say, oh yeah, pi over 4 to the right and 1 up, which you would not be able to do if you had the 2 inside, let's say. Okay, so it's a little bit different. Okay, amplitude, absolute value of A. I'll abbreviate with amp. Period, I'll abbreviate with PR. 2 pi over, strictly speaking, it's absolute value of B, but in almost no problems will they give you a B that's negative. So we can just say 2 pi over B. Okay. So I want you to put this template on your next cheat sheet. Y equals A, sine or cosine, B, parentheses, x minus c, plus D. Okay. Amplitude, absolute value of A. Period, 2 pi over B. Horizontal shift, just like before. Vertical shift, just like before. Okay, and I'll give you examples with this starting tomorrow, but we're timing out in about 1.5 minutes. So all I have time for a quick question, and that's about it. So let me stop the share. And this would normally be my stopping time anyway, but we'll see how it goes from here on out. Okay, any last minute questions before we get bumped out in about 1 minute and 10 seconds or so? Any questions, please? All right, and that'll do it for today, folks. Okay, so have a good day, and we'll see you next time. Okay, bye, everybody.